Welcome viewers. This is part 3 design of warehouse structures. In this we are going to look more detail about load combinations as per Eurocode for warehouse design. There are 3 set of load combinations as per Eurocode EN 1990 and second and third are ultimate limit state load combinations. Let me look more detail about this load combinations explanation. We need to consider the European standard EN 1990. There are 3 set of load combinations we need to consider. One is as per equation 6.14b of EN 1990, that is for SLS case serviceability limit states load combination sets, and the second one is 6.10a and third is 6.10b. both are ULS load combinations, that is ultimate limit states load combinations. And coming to that SLS load combinations, this is a general equations we need to follow as per 6.14b equation. So here that imposed load we are going to consider in two varieties, like one is for floor load, which is subject to storage areas for category E, and for category H is a roof load, imposed load, which we have considered already in our load calculations in the previous video. You can see in these calculations. So here that imposed load for all floors we have considered 7.5. This is to be considered as category E, and for category H to be considered the imposed load on roof, which is a maintenance here. So these are we already discussed in our previous video. So for these two cases imposed load we need to consider. So that is what mentioned here. So this chart, this table we have extracted from the EN 1990 with the national annexure of UK. So in the right hand side you can see that equations which we have taken from, and generally this 6.14 we need to find out from here. So you can see here these equations: sigma gk p plus qk1 qki sigma. So this means this gk is nothing but it is a permanent load or permanent actions. For example, it is a dead load and or self weight, and P is a pre-stress load which is not applicable for this warehouse, as we are going to do with the steel structures. And here this is UK QK1 means it is a leading variable loads such as wind or snow or imposed load we can consider, and QKI after this sigma, which is coming as a leading it is a accompanying variable load. So this whenever we are going to consider with combined with one more leading variable, so we need to multiply with this reduction factor 50. So this is what about this equations 6.14b. so that's why we have considered here those. And this table, if we are, this is a general table for both SLS and ULS load combinations. So for that we need to refer the national annexure. So here you can see in the right the table NA, that is for national annexure for UK, and these are the load combinations values given here. For category E it is 1 for 1 as a 50, which is a reduction factor, and category H it is 0.7. so like that this table is given. So we will look into that how it is going to combine and how this factor we are going to use. And coming to the calculation table, so these are the general load combination, that is a SLS load combinations. So for dead load we need to consider all as 1, because as per these equations there is no gamma factor. So you can see there is no gamma factor. Gamma factor is a partial load factor. So here only generally GK is given, so we are considering as a 1. And for QK also and QKI also there is no partial safety factor, so we can directly consider 1. But however, as per the national annexure load cases, we need to consider the reduction factor when we are going to combine the accompanying variable load with the leading variable load. So here are like this, we can see here. Next, coming to the imposed load, we are considering one for both imposed load category E and H. And in the next load combinations for E, we are considering 1, and for next variable leading variable loads, we are considering as 0.7. So that is why, as per this, for H we are considering 0.7. And coming to the next load combinations, it is here the variable load is only one variable load, that is snow load, so we are considering 1. When it is combined with the wind, so here we can see that wind is leading, we are considering factor 1 for both internal and external. IP is external, IP is internal pressure, so the positive and the negative are the positive wind pressure, internal wind pressure acting on the structure, and the negative is the suction, which is blowing outward or away from the structure. So these we are considering the leading load combinations up to here, and we are applying this snow load as a partial safety factor or a reduction factor 0.5. As mentioned here, you can see that snow loads on building for site location altitude less than 1000. So we are having a 50 meter as altitude in this demo design. So that 50 meter, which is less than the 1000 meter. So we need to consider this altitude, this reduction factor as 0.5. That's why that's what we have considered here for. So here the snow load is playing as a accompanying variable load. So that's why we are multiplying with the 0.5. And coming to this case, load combination number 8 and 9. So this here the snow is the leading variable and the wind is considered as the accompanying variable. So as per this, in the right hand side you can see that wind combination, it is 0.5. So that's what we have considered here. So this 50, 51, 52 are depends upon the importance of the building. So we are going to construct a tall, high range building which is going to store a lot of equipments, so that we need to consider this important category as 1. So next in the load combination 10 and 11, we are considering leading as a imposed load, that is load on roof, considering that with the combinations as 0.5 as wind load combinations, which is mentioned here, the reduction factor. And for uplift case and the internal pressure case, we are considering a dead load as 1 and the leading wind as 1. So this is what about SLS load combinations. Next, coming to that first set of ULS load combinations as per 6.1b, 1a. So here are the factors. You can see that equations which is explaining that how this load combination should be done. So in the right hand side you can see that there are two equations, 6.1a and 6.10b. So here you can see the gamma g. So here you can see the gamma g, g, k, j, and gamma p, p, which is not applicable as it is a pre-stress action. And coming to that next gamma q with reduction factor and qk, and these are the variable accompanying variable load and these are the leading variable. And here you can see that gamma g and gamma q with respect to the permanent and variable load combinations. So we need to find out this gamma g and gamma q. So for that we need to go to BSEN, National and Excel. So here on the right hand side you can see that the design value of actions. So this we are going to consider. So this equation 6.100a. So the permanent load for unfavorable condition is 1.35 and favorable load is 1. So that is what we have considered here up to 1 to 6 we are considering as unfavorable, and 7 and 8 is favorable in the left hand side Excel. So accordingly that variable action should be considered as 1.5 factor. So in this case we are considering 1.5 as a roof load, that is imposed load category H, and for another imposed, that accompanying variable load imposed load category E, we are considering 1.5 into the reduction factor which is stated here in this table. So for the imposed load for category E we need to consider 0.7. So we have multiplied this 0.7 with the 1.5 for the leading and variable actions. So we are getting 1.05. Similarly for yes, so similarly for next load combinations we are having only the dead load and the snow load, that is 1.5 the variable load combination we are considering here, and there is no reduction factor. And coming to that third and fourth, these are for wind load combinations, we are considering the 0.75 into 0.5 into 1.5, that is 0.5 is the reduction factor 5 value, that we are multiplying with this 1.5 variable load combinations factor, partial safety factor, and we are getting 0.75. So like that all these wind load combinations are arrived, and here that imposed load we are considering 1.5 as per this case. And next coming to that load combinations set as per 6.10b. So these are the load combinations. So in the right hand side you can see that for equation we need to multiply 0.925 with 1.35. So we are getting 1.25 load. So for the dead load we are considering 1.25, and followed by the variable load we are considering 1.5. So here the reduction factor we have applied, so 1.5 into 0.7 we are getting 1.05. Similar like this is variable load, main variable load, that is leading variable load, we are considered as a snow, it is 1.5. And here when combined with the wind we are reducing this with a reduction factor, as we are considering the snow as a accompanying variable load. So 0.5 into 1.5 as a variable load factor, we are getting 0.75. So for all the wind cases it is 1.5 we have applied here, both internal and external pressure coefficients. And followed by here it is a imposed load. As this imposed load we are considering as a leading, also we are considering this as a wind as a leading, because that equation says both are having the gamma 5 factor. And coming to the load number 18 and 19, so these are the, we are considering imposed load as a leading and a wind load as a accompanying variable load. And finally the uplift case we are considering, we reduced this to favorable dead load, favorable combinations. So we are considering 1 here, and the uplift case we are applying this 1.5 as per this load partial safety factor. So these are all about load combinations. So here in the Excel sheet you can see there are various lists here for the combinations, load combination detail which we have calculated just. So these are created for the, in order to feed to the robot structural model. So here that all the load numbers we have assigned here as 101 is a load combination for SLS, first load combination for SLS combination, followed by the series up to 191 we have considered, totally 94 number of load combinations we used to consider. And for equation 6.1a, these are the load combinations. So here we are going to consider from 1001, and for load combination 6.10b, so these are the load combinations which we have linked to the calculated table here. So this we are making in order to do our application, load application and the load combination application to the robot structural model very simple. We can just copy and paste to that robot structural table so that it can be generated. So this is what all about the load combinations which we have calculated, and we have arrived to make that robot structural input. Let we see in another video. Look description for more related videos and subscribe to this channel for more updates. Thank you.